All right, this is the in-class video for 613. We're going to go through this pretty quick, and we'll start with 626. And just so you're aware, we will be skipping 6-28. No need for you to worry about that. I'm just not going to go over that in-class or in here. Okay. Troy is a proud drummer of the Mini-Mites marching band. He has invited his fellow drummers over for a party. When he called to order 3 pies from the local bakery, he was told that each pie would be cut into pieces that are each 1/8 of a pie. Troy is wondering if he's ordered enough pie to share with all the drummers. How many pieces of pie will he have in all? Draw a diagram or model to show how you might represent this problem. So what I've drawn here is I've drawn the 3 pies, and I'm going to break them so that they are into 1/8 pieces, or basically into those 8 pieces, right? There we go. So how many pieces do we get? Well, here we have 24. I'm sorry, we have 8, another 8, and another 8 for a grand total of 24 pieces, right? So this we'll move to part B. This problem can be represented with a division sentence. Work with your team to write a division number sentence to describe this situation. Well, what did we do? We started with 3 pies, and we divided those into 1/8 pieces, right? So there's my division number sentence. And I could say, hey, what are those equal to? Those are equal to 24 pieces. All right, including Troy, there will be 12 people at the party. If all 3 pies are shared equally, what portion or part of 1 pie will each person get? Use the diagram if you are struggling. So the first thing we have is we know there's 24 pieces, right? And how many people are there going to be? And that's kind of what we've been working on in the licorice problems. We have 12 people, right? So each person is going to get 2 pieces. Now, I think it's important that labels are added on this, because if you don't label it, it could be 2 pies, 2 pieces. Which one is it, right? And what are those 2 parts, right? Well, that would be like this, 1 and 2, right? So how much of a pie is that one? How much or what portion of 1 pie will each person get? Well, 2 out of those 8 pieces, right? 2 out of the 8, or 1/4 of a pie. So notice that 2 pieces and 1/4 of a pie are equal. They're just different ways of describing that. Okay. Sarah had just made 3 fresh pies when she got a phone call from her boss, Glenda. Glenda, how many pies do you have so far? Sarah says 3. Glenda, that's only 1/8 the number we need for today's order. How many pies does the bakery need for the day? Draw a diagram or model to represent this situation and be prepared to explain your answer to the class. So what we've just discovered is that this part right here is only 1/8 of what she needs. So she needs 7/8 more, right? So she's definitely short of what she needs. That's only the 1/8. So if we doubled that, now that's 2/8. I don't know why it does that all the time. That's 2/8 of what she needs for the day. So we'll double that, right? And it's going to bounce down again, and I don't know why. There we go. Now we have 4/8. And if we double that one more time, what do we have? We should have 8/8. Right? We should have 8/8. So how many pies does the bakery need for the day? We need 24 pies. There we go. Work with your team to write 1 multiplication and 1 division number sentence to represent the situation. Well, in this case, we kind of were on that same way where we had 3 pies, but that was only 1/8 of what we needed, right? That was only 1/8 of what we needed, which was equal to 24, right? And I hope you're starting to see a connection here. In this case, I'll be a little bit more deliberate in that 3 and that 8 to get me that 24. So that is my multiplication. That is my multiplication sentence, okay? All right. So let's move on. 28, I said we'll skip, so we're going to move to 45. Is that the only one? We do have one more, okay. So this one is a modified problem from the book, and it's called Dora's Dollhouse, but we'll use the true version of it on 6.1.4. Dora's building a doll for her cousin. She needs several boards that are each 3/4 of a foot long. She went to the store and found that the lumber she needs is only sold in lengths of 6 feet. She laid a tape measure next to a board and drew the diagram below. Part A. Work with your team to figure out how many of the 3/4 foot boards she can cut from one 6-foot piece of wood. Draw a diagram or model to prove your answer. What I did is I drew the board into 6 feet, but I also, with the red marks, made them 3/4 each, right? So you can see that each one has been divided into fourths, and what we have is we have a 1, 2, 3, 4 fourths for each foot. And we need our pieces to be 3/4 of a foot, right? So that means that one piece is 3/4 of a foot. That's another piece. So it's piece 2, piece 3. And what we're going to do is we're just going to continue here until we get to the end. There we go. Whoops, I went too far. There we go. And last but not least, there we go. So we didn't answer the question. How many of the 3/4 foot boards can she cut from one 6-foot piece? Well, I'm going to make that a little bit bigger so it dominates that. Here we go. We have 1 piece, 2, 3, 4, 5, 6, 7, 8. We had 8 pieces from this 6-foot board. Okay. After she cuts her boards, how much lumber will be left over from the 6-foot piece? No lumber. Tomorrow, we will have lumber left over, and we'll talk about what to do with that. Okay. Represent this situation with a division number sentence. Well, we started with a 6-foot piece, and what did we do? We had to divide that 6-foot piece into 3/4 foot pieces, right? And that equaled, in this case, 8. If you follow kind of what we were talking before, notice that 6 times 4 would have been normally what we would have had, right? From up here, we had 3 times 8, right? But we have 6 times 4, and that's 24. How did we ever get to 8? Something for you to think about. All right, Mr. Benson's class is having a party. To help get ready, Michelle is putting salsa into bowls. She has 4 gallons. 4 gallons of salsa. That's a lot of salsa. And each bowl can hold 2/3 of a gallon. How many bowls can Michelle fill? So I created the 4 gallons there. And what do we notice? We notice that we need to divide them into 2/3 of a gallon. So there we go. Because that's all the bowls can hold each time. So much like before, what we're going to do is we're going to pour 2/3 of a gallon into a bowl. So I still have some left over in that big gallon thing, right? So I'm going to use another 2/3 of a gallon, 2/3, 2/3, another 2/3, and, oh, lucky us, for today, all of ours are going to work out nice. We'll always use all of the pieces, right? So how many bowls do we need? We need 1, 2, 3, 4, 5, 6 bowls, right? So we'll need, write a division sentence to represent that. Well, we had 4 gallons that we had to divide into 2/3, and we ended up with 6 bowls. Again, to emphasize that 4 times 3 got us to 12. How in the world did we get to 6, right? All right, last one. We really already answered that question. 6 bowls, right? There we go. That came from there. Okay. All right. If you have any other questions, please let me know. Have a great day.